In this video, I'm going to introduce you to equations of planes in 3 dimensions. So I want to try and approach it from an intuitive standpoint. So we're going to start with a line, something that you know, in 2 dimensions. So 6x plus 2y equals 12. That's the equation of a line. There's a set of x's and y's that satisfy this that would make up a bunch of points. And I could figure out a lot of those points. For example, say y was equal to 1. Well, then I could say 6x plus 2 times 1 equals 12, subtract, divide, x equals 10 over 6, okay? Which would be 5/3. I could come up with a whole bunch of numbers. I could list a whole bunch of y's and x's out. But what's easier to do, and what you learned in Algebra 1, was to solve for y equals 0. Or solve for y equals. If I do that, move the 6 over, divide by 2, I get negative 3x plus 12. Sorry, plus 6. And that I can graph using point slope, or using by graphing the y-intercept and then using the slope. So 1, 2, 3, 4, 5, 6, put a dot there, and then I go over 1, down 3, over 1, down 3. I draw my line like that. Now there's another way to do this, goes through that point right there, directly from this equation right here. And the reason I'm showing you this is because it's going to help us in a little bit. If I've got, I'll rewrite it, 6x plus 2y equals 12. Let's make y equal to 0. What's that give me? That gives me 6x equals 12, which gives me x is equal to 2. So what I can do is, on a coordinate grid, go to x equals 2, comma y equals 0, which would be right here, and put a dot. And then the next thing I can do is make x equal to 0. Well, what's that do in that equation? That gives me 2y equals 12 and y equals 6. So I can take the point 0, comma 6. So I can go up 1, 2, 3, 4, 5, 6, put a dot. And then I can, since I know that this is fundamentally a line, I can draw a line like that. Notice, graphically, this line, that line, they're the same thing. So, how do we get a plane? Well, if this gives me a line, if we add a z component, then we get a plane. Let me show you a little bit, and I will go through a more mathematical process to show you that this is true in a little bit. But for now, I just want to kind of focus on the intuition. If this is a line, what's the next step up in 3 dimensions? Well, it's a plane. So let's take 6x. I'm going to take 6x plus 2y plus 3z equals 12. So just take note that the 6x and 2y, they're the same as what I had here. So this piece here should show up somehow in what I'm going to work with here. And maybe you can figure that out thinking about what we did here. But let's go ahead down. So here's what I'm going to do. I am going to find some points in this plane. If you are at least partially convinced, and I'll convince you more as we move along, that this is a plane, all I need to do is get 3 points, because we know that 3 points define a plane. That's something you learned back in geometry, hopefully. So let's take x equals 0, y equals 0. What's that give me? All right, well, if this is 0 and that is 0, I get 3z equals 12, which gives me z is equal to 4. So that means that the point what is it here? I'm going to change colors to boom. The point 0, 0, 4 is on the graph. So actually, I'm going to go ahead and sketch this graph in like this, like we've learned how to do. And I'm going to put some ticks along the x-axis. Ticks here. Come on. Okay, so look, 0, 0, 4. Let's put that point on here. So 0, 0, 4. Oh, that's up here on the z-axis, right here. What's next? I'm gonna go ahead and do. I'm gonna do the same thing. I'm gonna let x equals 0, z equals 0. I'm gonna get a y equals something, and I'm gonna let next y equals 0, z equals 0, and get a x point. Why don't you pause and get those points? You should get y equals 6. Why is that? Well, if this is 0 and that's 0, 2y is 12, y is 6. And for this one, boom, boom, that's this and this. Those are both 0. You should get x equals 2. So that means that I get two more points out of this. I get, and I'm going to write them down below because I'm going to leave some space for some stuff later. 0, 6, 0. And then I also get, what do I get next? 2, 0, 0. So let's do the 2, 0, 0. Remember, this is my x, y, and z. So the 2, 0, 0 is out here. And then the 0, 0, 6, 1, 2, 3, 4, 5, 6 is out here. Now, I sort of showed this to some of you before, but what I can do is draw some lines connecting these things. And hopefully you can see that would be a plane in 3 dimensions. It would be the part of the plane that is in the first octant. The first octant is in 3 dimensions, where all of them are positive, just like we have the first quadrant in 2 dimensions. So that would be a plane that would continue out, and maybe I can like kind of shade it a little bit so you can see it, right? And it would keep going. But I want to show you some things about this plane. One, this is a way I can always graph a plane. If it's got like reasonable numbers, I can figure out points and stuff like this. But remember this up here where I had this line and that was the 6x plus 2y is 12? Well, I want you to see, and look, this was the y-axis. Oops, wrong. This was the y-axis and this was the x-axis. This is one of the reasons we have a right-hand system because, look, this is the y-axis, this is the x-axis. This line right here, line that I just highlighted is actually this line right here. If I were to not think of it as a line, as a plane, well, anyway, this segment of this triangle is the same as this segment right here. Because look, this is at y equals 6 and x equals 0. Same as this spot, y equals 6 and x equals 0. We just also have this z piece that is 0 as well. So one thing I can do is I can find the equations of this line right here in that xz plane. This, oops, is when, oh geez. Notice the y is equal to 0 in this spot because we are in the xz plane and there's no y coordinate for this segment right here. This reaches from here down to that spot right there. So if I set y equal to 0, I can get 6x plus 3z equals 12. Where does that come from? It comes from this guy right here and making that equal to 0. 6x plus 3z is 12. And if I were to go and graph in the xz plane like this, xz, then I could graph this line in the same way that I graph a line in 2 dimensions, and it would be equivalent to that line right here. Same thing here. If I let, what is it? What are we at here? We're in the YZ plane, so that means that x is equal to 0, and then I could go and look at this equation, make x equal to 0, get 2y plus 3z equals 0, and then I could graph this thing in the YZ plane. So hopefully that helps you see a little bit about these equations of planes. I'm going to stop this video here. I'm going to do another video on how we use the dot product to come up with a better version of this type of equation right here.